No, this has something separate.
Okay, here we go. So back to this. Ketones contain C double bond O in the middle of the chain. Now, one thing I didn't explain last week. If you go to table R, look in the third column where it says general formula, and then you look at any of them, there's an R attached to a bond. So if you look at ketone, you have R dash carbon dash R prime. What's R stand for? Yeah, it says at the bottom. R represents a bonded atom or group of atoms. They make it very vague, so I'm going to clarify it. If you see an R written next to these here, that R is just a carbon chain. Okay? That's all it is, a carbon chain. That means more carbons are going to be attached. So the difference between ketone and aldehyde is this R, right here. Aldehyde, you have an H on the side, and then carbons on the other side. Ketone, you have carbons on both sides. So if you look at the example, you have propanol, the carbon has 2 on the left of it, but only an H on the right. And then if you look at pentanone, 2-pentanone, you have the C double bond O with 1 carbon on the left, 3 carbons on the right. So the carbon is in the middle of other carbons. That's the difference between a ketone and an aldehyde, as far as what I want you to recognize. So that's a ketone. Notice it ends in -one. Ends in O-N-E. We don't pronounce it one, we pronounce it own, so ketone. That's how you recognize the name. It ends in an O-N-E, just like the functional group name, or the class of compound. And notice in the example it says 2-pentanone. Jess, why does it say 2-pentanone?
Because it's on the second one.
What is? You're right, I just want you to say it. It has the double bond up. Yeah, has this. The functional group is the second carbon. That's why it's 2-pentanone. So if I was to draw something that looked like this, go ahead and draw that, please. Get all your H's on there. If I was to do that, please copy that down. What would the name of that structure become? Don't say it. I want you to think about it. What would the name of that structure become? So using the example on table R, you have 2-pentanone as the example. There's the one I drew. What do you think the name of this structure is going to be? Catherine, what do you think? What would the prefix be? How many carbons do we have? You just have to tell me how many carbons we have. 6. So what's the prefix for 6? Hex. Good. So we know it's hex. And it's all single bonds except the double bond O. So we know it's hexanone. Now how do you know that? Here's why. This is here. Okay? If you see that, that means it's a ketone. What does that mean? It ends in O-N-E. So we know it's hexanone. Althea, what carbon is that? Third. So it's 3-hexanone. That's the name of that example on the board. 3-hexanone. 3-hexanone. Questions? I know I go kind of quick with the notes. I feel like I do. I only give maybe 1-2 examples because I'm going to give you a bunch of practice worksheets to help you. Because doing this is not helping you learn. You're hearing it, you're listening, you're writing it down. It helps a little. But practice is what's going to help you really get good at identifying, drawing, and naming. Okay? That's what's going to help. Questions? No questions on the ketone. Next. What's next? Organic acid. Okay. So, organic acids. Alright, so the organic acids are similar to alcohols. What would that be? Desiree, what does an alcohol and an organic acid have in common? Very good, the OH. Good job. So they both have hydrogen bonding. So organic acids, we'll start here, have higher boiling points due to hydrogen bonding. Good job. Hydrogen bonding. Now, someone in here on one of their journals said something to the effect of, how do I know which one has higher boiling point or lower or stronger boiling point or weaker or something to that effect. So this is a good example. and this goes for everything you learned all year, not just organic. If a substance has a high boiling point, who can tell the class what does that mean about its forces of attraction? If it has a high boiling point, Zach, what does that mean? If it has a high boiling point, does it have strong forces of attraction or weak? Strong forces. It's hard to break it apart. When you boil water, what are you doing to the water? Some little kid asks Caitlin, some little kid goes, Miss Curvin, can you tell me what happens when water boils? Because I'm just this curious, inquisitive little kid.
It gets really hot.
Good, it gets hot. And he'd say, well, what's that stuff coming off the top of the pot of water? What is that? What would you say? So when water's boiling, what's coming off it? You can see that stuff. Looks like smoke. Yeah, what is it? Yeah, but it doesn't look like the water in the pot. So if I was a little annoying kid, I'm like, what is that? Why is that? What is that stuff? It looks like smoke. Is the water on fire? And you say, no, it's steam. Good. The kids say, what's steam? Because kids don't know what steam is. You would? Okay. All right, that's fair. You did pretty well. What's steam? Water vapor. What does that mean? How's it different than liquid water? It's a gas. What happens to the particles to become a gas? Yes, they have to become further apart. So I'm really kind of explaining this for this one student, and I think a lot of other students can benefit. Two water molecules, I'm relating it to this, hold on. Two water molecules are held together with a force. When you boil it, that force is broken. So this water goes this way, this water goes that way. They spread out, and that's how steam is made. So when you boil water, you're breaking forces. So the point I'm trying to make here, for that student who wrote that and others who can benefit, this has higher boiling point. These organic acids, why? They have the same force. So it's harder to boil things with hydrogen bonds. Okay, that dotted line I drew keeps particles together longer because it's stronger. So you have to give it more heat. If you give it more heat, it'll finally break down. So that's the concept there. Higher boiling point due to hydrogen bonding. Also, they end in oic acid. That is the name, the end of the name for acids. So butanoic acid, propanoic acid, ethanoic acid, hexanoic acid. That's how that's how you identify the name. It has the word acid in it. That's pretty easy. But also oic acid. This one here, CH3, CH2, COOH. Or if I drew out all the bonds, I want you to draw both so you're familiar. Those two are identical. That's vinegar. That's the chemical compound for vinegar. And in real life, we call it vinegar. But if you wanted to sound super nerdy smart at dinner, you could say, please pass the, use the table R. How would you name this? Oh, that's not vinegar. I drew the wrong one, but that's okay. I'll draw vinegar in a second. But this would be called propanoic acid. Very good. I gave you the wrong one, sorry. This is propanoic acid. Vinegar is just 2 carbons. So vinegar is this one down here. Put a little star next to this one. So we call this one vinegar, but in real chemistry terms, we would call it what? What's 2 carbons? Ethanoic acid. Right. So next time you want oil and vinegar at a restaurant or at home, say, please pass the oil and ethanoic acid, please. People will look at you like you're crazy. But ethanoic acid, that's vinegar. There's another name for it. It's called acetic acid. There's 3 different names for that. So what am I trying to show you here? What's the point of learning this? How to name it, and this COOH group. Identifying. That means acid. Organic acids have the COOH group. So these are a little bit stronger than other organic substances. Why? That hydrogen bonding, the OH. Alright, so that's ethanoic acid and propanoic acid. I think propanoic is the one they give you, right? Yeah. So. Alright, let me draw another one here. Refresh your memory how to do this. See if you can name it. Alright. What if we have CH3, CH3, CH2, COOH. Bless you. I didn't know that was a bless. I didn't know that was a blessing. I didn't know that was a sneeze. Go ahead. Copy that. Try and name it, please. See if you remember the rule here. Try and name that, please. You awake, Zach?
Yeah.
Good. Alright, share with somebody. Tell your neighbor what you think the name is. You gotta tell somebody. Tell somebody what you think. And maybe they can help you if you need help. Annie, you can share with Sydney. Michaela, you can talk to Liam or Zach. You did? You good? Good.
I forgot about the chain part. That makes sense.
Alright, Abby. You're the one. Good job. 2-methyl-butanoic acid. 2-methyl. Why? Because there's the 2-methyl. So here's your methyl group right here. It's on the second carbon. 2-methyl, 1, 2, 3, 4, butanoic acid. Except, that's not right.
What? They're supposed to be.
Yes, who said that? That's right? Yes. Good job. It is 3. I was just playing along for a little while. Why is it 3? Functional group is number 1. Functional group gets the lowest number. That's the rule. Substituents come next. So that's the tricky one.
Why is it 3?
Because this carbon's number 1. 1, 2, 3. The functional group, this right here, this is the functional group, gets the priority, so it gets the lowest number. If you can't remember that, it's not the end of the world. Okay? I'm telling you, the most important thing to do is to be able to recognize that this is an organic acid. If you can do that, you're in a good spot. Okay? They rarely give you something like this to name. Okay? They do. If they're going to have you name something, it'll be usually a straight chain, something like that. Okay? So just butanoic acid. Or it'll be an alkane. So no functional groups, just single bond carbons. So don't stress too much about the rule, okay? If you remember, that's great, but I wouldn't lose sleep over it, obviously. Not that you probably would, but... Alright, so there's organic acid. So, the only thing to remember there is, the thing that isn't on here is hydrogen bonding, okay? Organic acids have hydrogen bonding. Alright, hold on, let me make sure I'm not forgetting something. Oh, they're also called carboxylic acids, because this is called the carboxyl group. That COOH is called the carboxyl group. Just throwing that out there. You do not need to know that. Oh, you know what? Actually, I wanted one more thing. What would methanoic acid look like? What would methanoic acid look like if I drew a structural drawing of methanoic acid? How many carbons?
It would just be the active functional.
It would just be the functional group. Good, yeah, with an H. That would be methanoic acid. I like to show this. Glad I checked my notes. because it's really strange. So it's just weird looking. It's just one carbon with two O's and two H's. That's called methanoic acid. Like Kai said, it has just the functional group, and then Zane said it's got to have an H, so it's got to have 4 bonds per carbon. So I always like to show the class that because it's a little bit strange. It's a little bit strange. Okay, next up, esters. All right. Now, I was going to hopefully have time to make one of these for you, but we'll do it in lab. You'll smell it. Anyone wearing perfume today or cologne?
Yeah.
Some of you, yeah. Well, just smell yourself. There you go. There's your demo for an ester. Or come up and smell the banana. This is producing the ester in the bananas is producing the banana odor.
What is everything?
Fruits, flowers, perfume, cologne, soap, deodorant, anything with any chemical fragrance that humans use, most likely is due to an ester, and then naturally it's fruits and some flowers produce odors due to esters. So not anything, because there's certain things that smell pretty bad that I don't think.
Wait, so esters is just good smell?
Sort of.
Well,
If you can make esters going wrong in a chem lab, it smells terrible. So some of you, if you kind of make a mistake when you're making your esters and you take the cork off and you make sure you waft it. If you stick your nose right, you're gonna, you kind of teary-eyed and all messed up. Don't do that. Some of those, if you mix up the combination, it doesn't
So
smell.
not all smells are esters?
No, not all smells are esters. I think that's what she was getting
What
at. No.
about gasoline?
Gasoline, that's just because of gasoline. That has a smell because that's the smell of octane.
Smells good.
It's not an ester.
It does.
In fact, octane would have the formula 1, 2, 3, 4, 5, 6, 7, 8. All C's and H's. I'm glad you brought this up. Good point. There's octane. Octane smells like gas. Not like we're going to draw because esters have this. So if you don't see this group, it's not an ester. So things like gasoline can have a smell, but it's not because it's an ester. It's an alkane. So it's a hydrocarbon, so it's different. So that's good. So anyways, yeah, esters produce odors. They produce pleasant odors. So things like fruit, perfume, cologne.
Ew.
That's how I remember to spell cologne. Flowers.
It does not smell good.
Cologne doesn't smell good?
Oh, I thought you said a lot.
No,
Like, I thought you were
no,
talking about
I was
bologna.
just playing. I was just being foolish.
Because bologna does not smell.
No,
That's
cologne is spelled, I think, strange.
Right.
All right, let's see if I'm forgetting something here. Oh, if you can smell something, what does that mean? I said this a long time ago. It's evaporating. Good. And if it's evaporating, what does that say about its forces of attraction? They're weak. Very good. So esters are volatile. You know what volatile means?
Unstable.
Unstable means it evaporates easy. Are volatile evaporates easily, which means you can smell it. You can smell them, and they have weak forces of attraction. Weak forces of attraction. So there are some things that we've said so many times that you guys definitely are remembering. I can tell when I bring it up. That makes you feel good. That's good. Things like that. These are general, huge concepts in chemistry that will help you on your regents. Things that you remember. So that's good. Yes, you can. So, volatile. What does that mean? Evaporates easily. That's an important word in real life people should know. So I think a lot of people think volatile means it explodes. That's not what it means.
I thought volatile was...
Volatile just means things evaporate easy. So nail polish remover is volatile. Gasoline's volatile. See, the problem is a lot of flammable things are volatile because the only thing that burns is vapor, not liquids. So like if you had a can of gasoline, you threw a match in it, it would catch on fire. But what would be burning is not the liquid, it would be the evaporation just above the liquid. So you have your liquid, and then the fire would be technically hovering above the surface of the liquid. You could like zoom in and check it out. Yeah, it is. In fact, I think I've seen it with specialized cameras. But anyways, that's the point here. Volatile. All right, now pleasant odors, fruit, perfume, cologne, flowers, dot dot dot. We'll do a lab on that, and it's kind of cool. It contains C double bond O with the O. You gotta have that. If it doesn't have that, it's not an ester. And it ends in, what does it end in? If you look at table R, what's the end of the name? O8. Right. These are not easy to name. I'm not gonna sugarcoat it. These are not easy to name. So, you guys been doing good, taking a lot of notes today, especially on a Monday. But we'll go slow, trying to name a few of these, and then if we don't get to the mean and the mids or mides, then we won't. But I think we will. I don't know. We'll see. So we'll definitely try and get this down here today. All right. And again, you do have homework, but I'm not giving it to you. I'll give it to you tomorrow in class. The sub will give it to you. Just don't forget to hand it in, okay, to the sub. Otherwise, you're gonna have to get late credit. All right. And I think what I'll probably do is I'll tell the sub to give you like the first half of class on your own, and then you can maybe work with somebody just to double check to make sure you know what you're doing. Because I don't want someone sitting here all day tomorrow with the worksheets not knowing how to do anything. That's not really going to help. So maybe someone can help you if you need some help. So we'll do that. All right, here we go. Esters. Let's look at the example. I like to use the example to teach where they got their name from. So I'm going to copy the example on the board, and then we'll talk about it. So what do we have here? CH3, CH3, CH2, C double bond O, O, CH3, right? Is that what they have? Okay. Now notice the name. There's two parts. Kind of like ethers. There's two parts, except it's very different. So it's hard to kind of relate this to anything else. So I see the two parts. What's the two parts? I see the methyl, and I see the propanoate. So I have the methyl, then I have the propanoate. So here's what I want you to do. When you find an ester, I want you to put a box around the functional group. So why don't you copy this down and do exactly what I'm doing. Put a box around the functional group. So there's the, that means it's an ester, right? That tells me it's an ester. What's up? What are you looking for?
I'm just trying to figure out a good way to get this ice crushed. I was like trying to do it.
And it's going all over the place?
Yeah.
Is it in a bag?
It was, and then, the bag just is like...
Oh, the bag broke.
Blows out.
Because you could just smash it in a bag, like
Yeah.
Hulk smash. But, Avengers, yeah, that's what it was.
I don't know. I mean, I got it down to pieces, like, not that big, but...
Yeah, I mean, I guess we'll just try, see what happens.
Yeah.
Are you going to do a dry run again? Or
No, this is going to be the real deal.
is it go time?
Yeah.
This is my second class with them, period 4. I may just try it, but I don't know.
Okay.
I may just run it through. Did it with just water last week, right?
Yes.
Was it good to do that first?
I think so.
Alright, so maybe I'll do the water today.
Yeah, because they were still, like,
Yeah,
trying to
okay.
figure things out, so...
That's fair. Okay.
And your freezer doesn't work, right?
Now, I have a bag of ice in there. I'm hoping it's still ice, not full of water.
Okay.
But
Alright.
I don't know. It doesn't work well.
Yeah, I think I'm going to stick this in there for now.
Yeah, go ahead. Let me see here. Let me know if that bag is still frozen. I think I have a bag in there.
Yeah, it's just water.
That's cool. So it doesn't really work.
Yeah.
Can you just take that out, throw it in the sink, please? Did it leak all over the place or stay in the bag?
That's in the bag.
That's cool. Great. Alright. Okay, back to this. So, methyl propanoate. How many carbons for methyl? Stay with me. Come on, don't run out of steam on me yet. 1. Meth means 1. What about prop? 3. Look at the example. Where is there kind of like 1 carbon by itself, and then where are the other 3? Okay. Where's the 1 carbon that kind of looks like it's by itself, and then where's the other 3?
It's in the middle. It's the second one from the right.
What is?
The carbon.
That's by itself?
Yeah.
I don't view it that way, but that's because I already know the
Not by
answer.
itself.
Which carbon isn't connected to any other carbons?
Oh,
That's a better way to say it. Which carbon is not connected to any other carbon? You have 4 of them. Which one is not connected to another carbon?
way right.
Yeah, way right. This is the methyl. There's your methyl. These 3 carbons here are your propanoate. And that's how you name these. It's not easy. I told you that. It's not easy. The way you name esters is you identify where the functional group is. I like to put a box around so I know what I'm dealing with. I know it's an ester. The carbon attached to the oxygen is always going to be your YL, your substituent. The rest of the carbon chain is going to be the O8. Again, there's no simple way to do this except practice and practice and practice. So this oxygen will always be in the middle of the chain. The carbon connected to that oxygen is always your YL. The other carbons with the double bond O, that's your O8. That's where the name comes from, methylpropanoate. Let me try another one. I'll make it a little easier. I'll draw it out. 1, 2, we'll do this and this. So go ahead and, whoops, what did I forget? The other O. Let's do that. Let's try and name this. So we know it's an ester because it's C double bond O. The carbon that's attached to the oxygen is the YL. So there's our methyl. The carbon attached to the oxygen is the substituent. Then these carbons here, these 2, are the O8. What's the prefix for 2? Ethyl. But, well, F. Except it's not ethyl because the YL is here. So this is ethanoate. Methyl ethanoate. Yes?
Wait, how come there's not the bond is molecular?
Oh, because oxygen only has 6 valence electrons. So it can only make 2 bonds. So 1, 2. Questions? So these are not easy to name because you have to remember 2 things. What the heck is